Jai Hind, myself Dr. Alok Vardhan. Currently, I am working as an assistant professor in the Department of Mechanical Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. Today, I will discuss the topic fuel cell. It is one of the important topics of the subject renewable energy resources. So, in this lecture, I will give the basic introduction of what is fuel cell, then what is the classifications of fuel cells, what is the working principle behind fuel cells, then what is advantages and disadvantages of fuel cells. So, basically in this lecture, first of all, I will discuss what is fuel cell, then what is working principle of fuel cell, means ki what is the phenomena behind the working of fuel cell, then different types of fuel cell I will discuss one by one, then what is advantages and disadvantages of fuel cells and its applications. So, first of all, what is fuel cell? So, basically fuel cell is a device that converts the chemical energy of a fuel into electricity. Okay, means it converts chemical energy of fuel into electricity with the help of chemical reaction which occurs inside the fuel cell. And what is chemical reaction? It reacts with oxygen and another oxidizing agents and produce electricity. Then in other words, we can say that it is an electrochemical device that combines hydrogen and oxygen. Basically, hydrogen is a fuel. It combines with hydrogen and oxygen to produce electricity, and it also produces heat and water. Heat and water, its byproduct, means it produces electricity and heat and water as its byproducts. Then there are many types of fuel cell, but all consist of three main parts. One is anode, another one is cathode, and third one is electrolyte. Means ki these three parts are present in every types of fuel cells. So, these three parts allows charges to move between the two sides of the fuel cell, means the electrons flows from cathode to anode. Electrons are drawn from the anode to the cathode through an external circuit producing direct current electricity. Means by the help of fuel cell we can produce DC type of electricity. The main difference among the fuel cell types is the electrolyte. So by the help of electrolyte we can identify what types of fuel cells are. Matlab, in other words, we can say that fuel cells are classified by the type of electrolyte they use. So according to different types of electrolyte, we can classify different types of fuels. Then what is the basic design features of a fuel cell? So the basic design features of a fuel cell consist of what is the electrolyte substance, what is the fuel that is used, what is the material for anode, and what is material for cathode. So I will discuss one by one. So basically the electrolyte substance usually defines the type of fuel cell. So, and what is fuel used in fuel cells? So the most common fuel is hydrogen. Then what is anode? Anode catalyst breaks down the fuel into electrons and ions, and the anode catalyst is usually made up of very fine platinum powder. And what is cathode? So basically cathode catalyst turns the ion into waste chemicals like water or carbon dioxide, and the cathode catalyst is often made up of nickel, but in sometimes it can also be nanomaterial based catalyst. So we can say that anode is made up of very fine platinum powder, whereas cathode is made up of nickel, या sometimes it is nanomaterial based catalyst. And the fuel that is used in most of the fuel cells are hydrogen. Then what is the working principle behind the fuel cell? So it working may be explained as the first is the cell consists of two electrodes between which electrolytes, here electrolyte is 40% potassium hydroxide solution, is filled and serve as carrying medium for a charged ion. So here two types of cathode, one is anode and one is cathode, and in between anode and cathode electrolyte is present. Here the electrolyte is 40% of potassium hydroxide solution. The fuel, usually hydrogen, is supplied at anode side and oxidant, oxygen, are at the cathode side. So here this is anode, so here we can supply hydrogen at anode side, and here at cathode region we can supply oxygen. Okay. The electrolyte between the inner face of the both electrode is kept stirred to prevent stay of ions for long time at the surface. Then the formed ion migrate through the electrolyte to the opposite sides of the electrodes because of pressure difference between the reactant gas and the electrolyte. So the movement hoga from anode to cathode due to pressure difference. Sometimes catalysts, generally platinum, are used to increase the reactivity at electrodes for breaking the fuel molecule. So we can use platinum as a catalyst to increase the reaction, to fast the process. So with the help of catalyst we can break the fuel molecules. Then during chemical reaction, H plus and OH minus are produced as an intermediate product. So the H plus ion migrate to the cathode and reacts with oxygen. So either H plus ion migrate to the cathode region and reacts with the oxygen and form water, H2O, and vice versa for oxygen ion, and oxygen has moved from cathode to anode side. The electrons released at a anode traverse through the external circuit to form the oxidizing products and produce the electricity. So the electron released at anode traverse to the external circuit, and produce the electricity. And this is DC type. Then now I will discuss different types of fuel cells. So here there are four types of fuel cells. First one is phosphoric acid type fuel cells. In short, we can say that PAFC. Second one is molten carbonate fuel cell, MCFC. Proton exchange membrane fuel cell, in short, it is PEMFCs. Solid oxide fuel cells, SOFC, and fourth one is regenerative fuel cells, RFC. So the whole fuel cells are classified into these four types: phosphoric acid fuel cell, molten carbonate fuel cell, proton exchange membrane fuel cells, and solid oxide fuel cell, and last one is regenerative fuel cell. So in subsequent slide I will discuss one by one what is phosphoric acid fuel cell, what is molten carbonate fuel cell, what is proton exchange membrane fuel cell, what is solid oxide fuel cell, and what is regenerative fuel cell in detail. The first one is the first types is phosphoric acid fuel cell. In short, it is PAFC. It is denoted as PAFC. This is the schematic representation of phosphoric acid fuel cell. This is anode, this is cathode, and in between anode and cathode, phosphoric acid is the electrolyte. So in this cell, phosphoric acid H3PO4 is used as a non-conductive electrolyte to pass positive hydrogen ions from the anode to the cathode. From the anode to the cathode, positive hydrogen ion transfer from anode to cathode. PAFC is a non-conductive liquid acid which forces electrons to travel from anode to cathode through an external electrical circuit. Then what happens? The hydrogen ion production rate on the anode is small, so platinum is used as a catalyst to increase this ionization rate. So here we can use by the help of platinum, we can increase the ionization rate of this hydrogen. Then these cells commonly work in temperatures of 150 to 200 degrees Celsius. So phosphoric acid fuel cell are used at the temperature of 150 to 200 degrees Celsius. This high temperature will cause heat and energy loss. So if the heat is not removed and used properly, so here we can ensure that there should be proper heat transfer. Okay. Then this heat can be used to produce steam for air conditioning systems or any other thermal energy consuming system. The chemical reaction in this fuel cell are as follows. So this is the chemical reaction. Here the reaction at the anode side is this. Here hydrogen breaks into 2H plus and plus 2 electron, and the cathode side reaction is half O2 combined with 2 hydrogen molecules plus 2 electrons and give H2O. So we can say that the overall chemical reaction of phosphoric acid fuel cell is here hydrogen plus half O2 combined and produces H2O and delta E, and this delta E can be used for production of electricity. Then second type is molten carbonate fuel cell. Molten carbonate fuel cell. So in this fuel cell, mixture of hydrogen and carbon monoxide is used as a fuel and O2 or air as a oxidant. So here hydrogen and CO is used as a fuel and oxygen or air as a oxidant. MCFC use lithium potassium carbonate salt as an electrolyte. Okay, so in this fuel cell we will use lithium potassium carbonate as an electrolyte, and this salt liquefies at high temperature, allowing for the movement of charge within the cell, and in this case negative carbonate ions. Working range of such fuel cell is 6500 degrees Celsius to 7000 degrees Celsius, very high. Then the hydrogen in the gas reacts with carbonate ions from the electrolyte to produce water, carbon dioxide, electrons and small amount of other chemicals. The electrons travel through an external circuit creating electricity and return to the cathode. Then oxygen from the air and carbon dioxide recycled from the anode react with the electrons to form carbonate ions that replenish the electrolyte, completing the circuit. The chemical reaction can be expressed as here. This is the anode. It is made up of basically this is anode and this is cathode. Here we can use hydrogen or carbon monoxide as a fuel and oxygen or air as a oxidant. So here fuel is hydrogen, yeah, carbon monoxide, and oxidant is O2, yeah, air. And the electrolyte, the in between cathode and anode, here this is electrolyte, and here the electrolyte is molten carbonate fuel cell. So if you are talking about its chemical reaction, so at anode side, carbonate plus hydrogen combined and gives water, carbon dioxide and 2 electrons ion. Then carbon monoxide plus this carbonate combined together and gives 2 molecules of carbon dioxide and 2 electrons. Then at cathode side, carbon dioxide plus half O2 combined with 2 electron ions and gives carbonate CO2 2 minus. If you are talking about this overall chemical reaction of molten carbonate fuel cell, so it is hydrogen का 1 molecules combined with 1 molecules of carbon monoxide and 1 molecule of oxygen produces water, carbon dioxide and delta E. Delta E means heat. Now the third type of fuel cell is proton exchange membrane fuel cell, PEMFC. So these are also known as solid polymer electrolyte fuel cells, SPEFC. In this type of fuel cell, solid polymer membrane of an organic material such as polystyrene is used as electrolyte. On the anode side, the H plus ions are conducted through the membrane to the cathode, but the electrons are forced to travel in an external circuit because the membrane is electrically insulated. On the cathode catalyst, oxygen molecules react with the electrons which have traveled through the external circuit and protons too from water. The chemical reaction which can occur here is at anode side, hydrogen breaks into 2H plus and 2 electrons, and at cathode side, half part of oxygen plus 2H plus combined together with the help of 2E minus and produces water. If you are talking about its overall chemical reaction of proton exchange membrane fuel cell, then its overall reaction is hydrogen 1 molecules and half molecules of oxygen combined together and produces water and delta E means heat. So here in this type of fuel cell, this is anode, this is cathode, and in between anode and cathode, electrolyte is polystyrene. Here fuel is H2 and oxidant is O2. Okay, and electrolyte is polystyrene. The another fuel classification is solid oxide fuel cell. Solid oxide fuel cell. So in this cell, a solid material, most commonly a ceramic material, used as the electrolyte. They require high operating temperatures, 800 degrees Celsius to 1000 degrees Celsius, due to which no catalyst is required. The anode in such cell is made up of porous nickel and cathode is made up of metal oxide. The output voltage is about 0.65 volt at about 8000 degrees Celsius. Generally, H2 is used as fuel in this cell, but other fuel may be methanol, ammonia, and hydrogen. This cell having efficiency about 60 to 70%. So, in solid oxide fuel cell, fuel is hydrogen, but we can use another fuels like methanol, ammonia, and hydrogen. And the catalyst here, electrolyte is ceramic type material. And this type of fuel cell produces the efficiency about 60 to 70%, and it by the help of this solid oxide fuel cell we can obtain the voltage nearly 0.65 volt at temperature 8000 degree Celsius. So this is the solid oxide fuel cell. The another one is regenerative fuel cell, RFC. What is regenerative fuel cell? A regenerative fuel cell or reverse fuel cell is a fuel cell operates and run in a closed loop. This type of fuel cell are operate in a closed loop where reactants are regenerated from the product. So here we can regenerate the reactants with the help of products in regenerative fuel cell. This cell produce electricity from fuel H2 and oxygen and generate energy and water as by a product. The excess water is divided into H2 and O2 by electrolysis using electricity from other sources like solar, wind, etc. So, in regenerative fuel cell, fuel is hydrogen, oxidant is O2. So, this H2 plus O2 generate water and byproduct. Okay. So, here this is the schematic representation of regenerative fuel cells. So, if you are talking about its chemical reaction, so here at anode side H2O means water combined with 2 electrons and gives hydrogen plus oxygen molecules. Then at cathode side O2 minus breaks into half O2 plus 2 electrons. So if we are talking about this overall chemical reaction, so here hydrogen breaks into oxygen plus hydrogen. So this is all about for regenerative fuel cell. So now I will discuss what is advantages and disadvantages of fuel cells. So as we know that fuel cell is used to produce electricity, means here we can convert the chemical reaction of fuel into electricity. There are many types of fuel cells which I have already discussed. Now what is the advantages of fuel cells? The first advantage is less pollution and higher efficiency, means fuel cells have higher efficiency compared to other form of electricity generation. Then it is also less polluted. Then less maintenance required, means in fuel cell there are no moving parts, so its maintenance is also minimum. Since there is direct conversion of energy, so efficiency is high. Here direct conversion means chemical energy is converted into electrical energy. So due to this the efficiency is high. Then another advantage is water is formed as a product which may be used for many other applications. So here hydrogen and oxygen combined together and produces water, and this water can be used further may be used for many other applications for producing steam and so on. Then having fast starting time. Okay, so this type fuel cells have fast starting time. So these are some advantages of fuel cell. Now what are the disadvantages? So first one is high initial cost. Initial matlab initial value. So here the fuel cell have high initial cost, but its maintenance cost is minimum, but initial cost is very high compared to other electric generation devices. Then second one is short life because of degradation of electrodes. So the lifespan of the fuel cell are also short. So it has short life because of degradation of electrodes. Third one is proper handling is required due to operate with hydrogen and oxygen. So this is very dangerous types of these gases, hydrogen and oxygen. So proper handling are required to operate with hydrogen and oxygen. Efficiency goes down with time. So it is the efficiency of fuel cell depend on time. So with respect to time, efficiency goes down. Then what is applications of fuel cells? The first application is used in automotive vehicles. All the automotive vehicles have fuel cells. Power generation up to 1 megawatt means by the help of fuel cell we can generate, we can produce the electricity up to 1 megawatt. Then used for space application. Okay, for space application we can also use fuel cell. Used for military application, fuel cell can be used for military application. And last one is used for submarine application. So in short we can say that fuel cell should be suitable for automotive vehicles, space applications, military application, submarine application, and by the help of fuel cell we can produce 1 megawatt electricity. Then what is the present status in India? So in India, fuel cell technology is in developing stage. It is supported by Ministry of Non-Conventional Energy Sources and financially supported to import a 200 kilowatt phosphoric acid fuel cells. Okay, lots of research and developments are involved in this field. Bharat Heavy Electrical Limited (BHEL) is developing a 50 kilowatt fuel cell power plant. Okay, so in India, fuel cell technology is in developing stage, and it is supported by the Ministry of Non-Conventional Energy Sources and financially supported to import a 200 kilowatt phosphoric acid fuel cells, and lots of research and developments are involved in this field. And BHEL already developed. BHEL is developing a 50 kilowatt fuel cell power plants. So these are the present status regarding fuel cell in India. So if we summarize the whole lecture, so we can learn what is fuel cell. So basically fuel cell is a technology by which we can produce electricity with the help of chemical reaction. Okay, so there are three parts of fuel cells. There are three main parts of any fuel cell. First one is cathode, second one is anode, and third one is electrolyte. And by the help of electrolyte, we can categorize in which types of fuel cells are. Okay, and if you are talking about fuels, so hydrogen is mainly used as a fuel. Then if you are talking about oxidant, so oxygen is used O2 used as a oxidant, and there are different types of electrolyte. So this is all about for this lecture. Thank you for watching.